Hello, welcome back. A warm welcome from SL Rec, and from me personally, of course, so that you can join us for our last online seminar of the day. We are close to the swimming pool today, which we all deserve. You, of course, have a huge advantage over me now. You are already off work. You just need to listen now, and then you can head off for the evening or leave the company. I still have to keep working. I need to tidy up. All the mess I've made here, I have to clean up. But that's another story. It's nice to have you with us. You can use this time actively. This morning, we already had an incredible number of viewers, listeners, and participants in our seminars, which is a great sign for us that SL Rack has the right products for you, which are comprehensively important for you. You bind them and thus captivate them somewhere, and your product is something they enjoy working with, so they are well equipped in the flat roof area and can see how to assemble it. All of this quickly. Why is it called Fast Flat? For those who are joining us for the first time, I will show you this in the next 25 minutes. Here on the ground, you can already see the base shoes. We will assemble east-west live, corner clamping, quarter point clamping. We will set up south, and I want to introduce you to the components and parts. For those who know how it works, feel free to stumble upon the Pee-wee Guide tour and take a look at what else was happening with us at Intersolar. We have many more updates, which we won't discuss today, but I just want to share them with those who don't know us yet. In the background, you can see our current flat roof system, the Generation 2 system, and the Fast Flat, which is featured in this presentation. I will explain in more detail. The old system will not be replaced, nor will the current system. The new system will be added instead. With Fast Flat, it is important to us that it is quick and requires little storage space. Let's stay briefly with the photo and maximum build-up. You can see here, no gaps, no wasted space on the roofs, maximum build-up while considering ground pressure and roof insulation. It is very important to us that this is considered, and in this regard, we naturally retain all the flexibility that we had with the previous system. That means maintenance walkways, wind deflectors, adhering to friction coefficients. These are the topics for us. We will start directly with the presentation and take a look at everything. There stands perhaps the fastest system on the market. I would now say the fastest system on the market historically, if you look at the systems available. Everything is pre-assembled. That means, if we just talk about the base rail, we have pre-assembled the holder. And then I could begin assembling. I need little storage space. I have the ability to clamp all module sizes, clamp all module lengths. We have included our tilt joint theme, which is very important to us. By the way, we were the inventors of this, no one else. We were the inventors in the Generation 2 and Generation 1 systems. And now we see that the market is improving in this regard everywhere. Because it is essential to remove all tensions from the module with a continuous rail system, which we have here, plus a swivel joint. We deal with aerodynamics and wind in the flat roof area, implemented in our Solar Pro calculation tool. The wind is essential to ensure everything stays on the roof because we have a non-penetrative mounting system. That means forces are already acting due to the wind. Now imagine you have a mounting system that has no tilt joint, stands perfectly on the roof, is easy to install, and still has no continuous beam, no continuous rail, no tilt joint. What do you think will happen to the module? Can you fly the drone? When you look at the roof, check how many hotspots appear. If it is a glass foil module, eventually the foil will tear at the transition between the frame and the foil on the back. Glass modules, we'll see what happens there. But basically, you can already take preventive measures in advance to get the most out of your system or for you in plant construction. Stress-free installation, ideal load distribution, we are lightning current capable, and we have cable management included. I have a module optimizer here that I would like to show you how to secure properly. The module width in the clamping area is 1.4 to 1.13 m. No limit on module length. It doesn't matter if it's 1.72 or 2.50 m. You can do whatever you want. I will show you shortly what to do if you get stuck at the quarter point. And here is the last or second to last sentence. Lightweight modules ready. I mentioned it earlier, for example with the facade system Eco. I saw in the show truck these lightweight modules with frames, which are also possible to mount here. So we are compatible with that, and the most important thing is that it is 100% made in Germany 2001. And if we want to be even more specific, we can say made in Bavaria, or in Upper Bavaria in this case, because we produce it ourselves. That means we don't source anything from elsewhere. We are talking about a steel system here. Now when you say steel and aluminium, what are they doing? No, we know that steel works because we roll out several GW of ground-mounted systems each year. This is the same steel for the same level of corrosivity in the open area. Therefore, we know that it works. Runtime 2025, 30 years, no problem. We start with the component. You are warmly invited to participate in the chat. So if you have any questions, or if I am speaking too quickly and you can't follow, please feel free to ask your questions and share anything that is on your mind. The system setup is as follows. With just one of these rails, you have the possibility to set up south, east-west, and both systems, that is, south and east-west, in corner clamping and quarter point clamping. This means that corner point clamping would be the clamp here on the short side, and quarter point clamping is the clamp at the quarter point. So, now it gets a bit tricky. At the quarter point the module and thus have the possibility to cover everything. Once again, a rail for everything, the same module clamps as from the pitched roof area, or from the existing flat roof system, or wherever you are already using the module clamps. This means that only 3 or 4 new components are added, and then you have the flat roof system implemented. The south setup, as I mentioned, one after the other. For the south setup, we have placed importance on using 3 wind deflectors, 2 new ones made of steel and the existing wind deflector from the Generation 2 system, which can also be used. This means you don't have to throw anything away, you have no stock value, and you can continue working with the wind deflectors. Now, it is like this, 2 wind deflector sheets for the reason that we have the possibility to mount a wind deflector sheet completely vertically at the back here. That is, flat at the back where my left hand is visible. However, this requires more ballast, calculable in the Solar Pro Tool software, and the wind deflector in the standard, where I have little additional load, has a radiation angle of 60 degrees 2001. The base rail, as I mentioned earlier, is pre-assembled, so you don't have to do anything here. This means you take it from the pallet, fully pre-assembled on the back with holes, so you can also mount it on trapezoidal sheet metal with an EPDM in between, thus also having an elevation for trapezoidal holders. It is pre-assembled, and the tilt joint at the top is designed so that I can mount 2 clamps at the top. Either a middle clamp for the corner point attachment, and now I take the lower side, or perhaps even an end clamp, like for instance, the quarter point attachment used, and then for this we have 2 small stop lugs here again, so that you always have precisely the correct attachment needed specifically for these PV modules. This means you place a module while assembling it carefully and let it tilt backwards slightly, so then you can thread it in cleanly right here. This is the base rail, and now there are these intermediate pieces. The intermediate pieces 2001. In 3 different lengths, 220, which means here at the back, or also at the front bottom, depending on how you want to make the maintenance channel, all calculable, 390 and 700, with 700 being more towards the south system, in the east-west area, 220 is, let's say, the measure. You shouldn't need more because, of course, it would become uneconomical somewhere along the line. About the base shoes, we have two sizes. One is the base shoe, the light base shoe and the large base shoe. The light base shoe has a contact area of 10 by 200 millimeters. The large base shoe has 200 by 200. It is important to note that the small base shoe is made of PVC and the large base shoe has an extremely slip-resistant EPDM. This EPDM has the following coefficient of friction, which is better on the roof, or, simply put, the substructure slides off the roof less quickly if it is laid incorrectly. Now it is very, very important that you listen here. So, the base shoe is essential for this system. We have roofs with hard insulation or with soft insulation. If they have soft insulation, they cannot cause any loss of insulation value when building a substructure on it. You are only allowed to apply certain pressures or support forces on the underlying roof membrane or the insulation. And we can compute these values in the SolarPro tool. This means that as an installer or planner, you only need to know what insulation you actually have underneath. It's often hard with an old building, 40-year-old, to know what kind of insulation it has. I have to assume some factor, but do not neglect it. It is essential to properly design the ground pressure. The topic of ground pressure and the coefficient of friction is important. The coefficient of friction and the measuring case. By this one, it costs relatively little. You will have it for a lifetime, and whenever you need to measure across a flat roof, you can pull the block over it. This is defined with a small user manual, and you can represent the coefficient of friction incredibly accurately in any planning. It is important to note these base shoes. I will just do it here. Look as follows. I hope you can see this here just as an example. Now simply take the large base shoe and click it right in here. You heard, the base shoe is secure, it locks in here. We will look at this in detail later. It is important to note that having a base shoe there does not mean that the ground pressure is correct. You can clip up to 3 more large base shoes or small base shoes into the rail here. Once here, here, and here, they have a maximum contact area of half a square meter or more, depending on what we install, and thus the maximum or minimum ground pressure for your extremely soft roof. I hope I have been able to explain this reasonably well, and that it serves as useful information for you. Ballasting is natural. It works exactly against what we aim to achieve with the large base shoes. We naturally want the smallest bearing surface, or the largest bearing surface for the least pressure. But the ballast naturally counteracts. So, now when ballasting, we have the option of using a ballast angle, which I span over the basic frames with 2 pieces, then place stones in and secure with the universal clamp. However, we favor maximum ballasting on the substructure through the software. That means we calculate everything. You have the option to work with small stones on the substructure. I recommend using stone slabs weighing around 15 kilos, and then you can fit several slabs in here. I believe it's 5 or 6 pieces. When the module is, you have maximum ballasting determined by the SolarPro tool. When the wind becomes so strong that this no longer works, they have the option to set up a ballast wall. That is up to the ballast angles inside. Sorry, not ballast wall. The ballast angles are to be secured with the universal clamp over these long holes here, or with the additional ballast clamp, which can be mounted without tools, but we will only include it in the program later. It is not ready yet. I can honestly say that at this point. If you can't wait until then, feel free to check out our download page. But I believe we have already anchored the catalogs in the chat, so please take a look at them to see which products are available. The quarter-point strut, as the name suggests, is a component specifically designed to ensure stability on the roof during quarter-point insulation, and it does so effectively. That means you have to imagine, while in this system the modules are clamped on the short side in the background, wind suction force is transferred to the modules above or to the ones standing on the side. With a quarter-point clamping, each module row must be considered individually. That means we have a static disadvantage compared to corner clamping. To counteract this, we have the option of using this quarter-point strut, which runs over 3 rails, over 3 base rails. I will gladly show you during the setup how to hang and mount the whole thing here, and it is fixed in place with the holder. This means that if wind forces occur here, the whole system is so rigidly braced, our system in width and, or in other words, the module area we have on the roof, in a rectangle or in an area, is completely interconnected. But this is only if they build a quarter point. If they build a corner point, they do not need this strut. Yes, rear wind deflector sheet, 2 pieces, one here and on the next slide. We will look at them in detail shortly. Here is the wind Lieblich light, which then requires more ballast because it is naturally exposed to pressure from behind. Cable management and the possibilities for optimizers and so on are very important to us. And I would like to briefly show you how this is possible, for example, in the area of optimizers. I hope you can see it here. I have a no-name optimizer here. No, I have an optimizer from a well-known Israeli company and I attach it very easily here to my substructure. Optimizers on, secured it. Cables. Optimizer not fully secure. Now we have a bunch of cables, and the cables can be placed in the base tray. This means I have the option here to lay cables in my tray, make cables disappear, secure cables, and already use this tray in the cable management too, as I want to show in detail with the 2001 camera. Potentially avoid using cable trays, because you can already lead a lot of strands to the inverter underneath here. Anyone who wants to fasten the module cables can use this simple cable clip. It is very small, or in other words, I have quite large hands, making it feel tricky to fasten this component in place. And thus, it is possible to clamp MC connectors, modules, or other items in here again, up to 8 cables, but you won't need them in this area crosswise. And the cable clips are also being prepared for attachment at the quarter-point strut. Let's take a look. What else do we have? Lightning protection and current capacity, which is important as we continuously carry lightning current. We will also be using this system. We will be at that point. That means I have the final certification. The document is not yet available, but we know from history that all systems, because they are consistently tested by us, we know what matters. Here too, it is possible to integrate the almost flat system into the external lightning protection. This means if they cannot keep distance from air termination systems and lightning current air termination systems, the substructure can carry lightning current. You can confidently equip any petrol station, any building with it. How do we do that? With the extremely well-known lightning current clamp from above, which we click into the channels that are on top here, and then connect with the round rod road or road through. For the moment, as I mentioned earlier, you should buy it, you ought to buy it. I recommend it to you again with an explanation of why that is. We have different friction values on roofs, meaning one is bitumen, another is foil, and another is a foil roof in the north of another building in the shade, where there is verdigris. That means our base shoes, and also those of our competitors, it must be said, as everyone is essentially in the same boat, need to test the friction value here. This should be implemented in the Solar Pro tool during planning or in the new Peewee cloud once we have completed the new software. And in this regard, the ballasting is included according to the friction value, the wind, the location, and so on. If you have any questions about this, please feel free to contact us. We are happy to support you. And now, almost as if I were to kneel before you, we will start the installation, but to show you that I don't have to kneel, I will now demonstrate how to install ergonomically nowadays. That means we are now installing east-west, and with east-west it looks like this. I don't kneel down, but place the rail in, click, down, and do the same here. So, in the end, I can install everything completely on my own again. Stop, that was my mistake. I can assemble this completely on my own. Then the first rail is on the roof, now the next rail comes. So we can continue building endlessly. I still have my cordless screwdriver in my pocket, or in my trouser pocket, but no one needs it because it is completely tool-free. I fold the whole thing up and have my east-west system ready. Did you see that? It couldn't be easier. That means, now I place the module on top, and I'm done. That means, this is my module with 1.75 or 2.20 m. The system is complete now, I am almost done. I still need a base shoe here, I forgot about that. That means I still need to install the base shoe here. Then it will be in place, and my east system will be complete, and I can continue with the next rails. It doesn't get any easier than this. I will set up the same thing here again, and show you with the quarter-point strut, when the system or the module, as here, needs to be mounted at the quarter point. So, we assume we are at the quarter point, then I take my strut, my quarter-point strut, and place it here in the system. To begin with, let me explain what a quarter-point strut is. A quarter-point strut is a structural component that is specifically designed to be mounted at the quarter point of a system or module. This is crucial for ensuring the stability and balance of the entire setup. Now, I will carefully position the strut at the designated quarter point. This involves aligning the strut with the pre-marked quarter point on the system. Once aligned, I will secure the strut in place using the appropriate mounting hardware. This step is essential to ensure that the strut is firmly attached and will not move or shift during operation. After securing the strut, I will double-check the alignment to make sure it is perfectly positioned. This is important because even a slight. To make the entire process work effectively and efficiently, I still need to take an additional third rail here, and thus connect all of my components over a span of 3 rows in order to ensure proper functionality. I just hope you can literally see it clearly. I simply fold the holders up right now, and here is the last one. Now, in this case, if the wind blows and pulls exactly here on the module upwards, without a quarter-point strut, without this cross-connection, it would pull this module row upwards. This does not happen because we have installed the cross brace. This is to explain how the whole thing works. Now let's briefly move to the south system. With the south system, I have the situation where I have a gap to the next rail. In this case, I want to work with a gap of 700. Click the spacer plate in here for me, please. Kindly bring the next base shoe into the main rail and get me another rail, if you could. Now I don't have any more that fit. I simply don't produce them, you can imagine that, and I just need to attach my wind apron here. This means that with 3 different spacers, 220, 390, 700, I have the possibility to adjust my distance in the south system. Wind deflector light is again relatively simple. I clamp it at the back, clamp the entire sheet, screw it tight with self-drilling screws, and have secured my wind deflector sheet at the back. And if I use my standard wind deflector, then I can hook it in down here and also attach it at the top, just with a larger angle of inclination. Can we zoom in again briefly so that it can be seen better? Exactly. You can see here the guide plate, which is locked at the bottom and has a noticeable tilt at the top. It's a bit difficult to see. So theoretically, I could unfortunately install it, but no one needs it. This looks like when finished. This will be made clearer in the installation video, which will be created on YouTube shortly. Therefore, follow our YouTube channel where I think the facade is included, as well as the almost flat system. Because what we are doing here in the short version, I want to show you how easy it is to assemble the whole thing. That means with the basic frame, the standard module clamps, possibly a quarter-point strut and the base shoe or just a base shoe with 4 components, you have the possibility to already build a complete roof with a 160 kilowatts basic frame on the pallet. I think this is a significant added value for you in the system. I have to say, it is the fastest and best system on the market. Not because we developed it, but because we know it. That's how it is. We took a long time to develop it, and therefore I am happy about every inquiry, every contact, and feel free to test the new Fast Flat system in the Solar Pro tool for all those who are familiar with the Solar Pro tool. On the roof page, you can select Flat Roof Generation 2 and Fast Flat. I'm also happy to wait for your feedback. Let us know if you find anything you like or dislike. Feel free to contact us if you think you need something added. We are happy to do that. In this sense, it's off to the outdoor pool. Tidy up and looking forward to hearing from him soon. Thanks, bye and cheers.